Alright, we're going to continue writing linear equations in both the slope-intercept form and the standard form. However, this time what we're going to be given are 2 points, 2 ordered pairs. So we're going to start off with slope-intercept form. That's that y equals mx plus b. And again, all I have at this point are 2 points, the ordered pair 2, 6 and 4, negative 8. So it's going to require a few steps here. I'm going to go ahead and label my steps A, B, and C. So first part, A. First thing we're going to need to do is find our slope. And we discussed this in a previous video on how to find the slope. And what we're going to do is use this little formula here, y2 minus y1 divided by x2 minus x1. This is how we find our rise over our run, or our rate of change. Alright, so my second y value minus my first y value. My second y value was a negative 8. I'm going to subtract the first y value, which is a 6. That's this number here and this number here. We're going to do the same thing with the x's. We're going to take the second x, which is a 4, and we're going to subtract that first x, which is a 2. So let's see what we get here. Negative 8 minus 6. When I subtract negative 8 minus 6, I get a negative 14. When I subtract 4 minus 2, I get 2. So I get negative 14 over 2, which obviously can be reduced. Negative 14 divided by 2 gives me a negative 7. So I now know my slope, or the letter M, is going to be a negative 7. So I've got part of what I need here. Now that I know the slope is negative 7, the second thing we're going to do is we're going to use our point slope form, and that's this one right here, y minus y1 equals m times x minus x1. And we use this anytime we have a point and a slope. And as you can see, I do have a slope, and I even have 2 points here. So the question is, which point or which ordered pair do we use? Now it really doesn't matter. I can use the ordered pair 2, 6, or I can use 4, negative 8. That all depends on you, whichever you think looks easier to work with. In my case, what I'm going to do is I'm just going to go ahead and use the ordered pair 2, 6. But I could very easily use the other ordered pair 4, negative 8. So what I'm going to do is start by replacing the y1 with the y value, which in my case is the 6. Remember, I'm using this ordered pair right here. M stands for slope, which I just found. We found out that that was a negative 7. And next thing I'm going to do is replace that x1 with a 2, because that's our x value in that ordered pair that I chose. So I now have y minus 6 is equal to negative 7 times x minus 2. What I'm going to do now is go ahead and simplify this. So to simplify this, I'm going to start by using some distributive property. Negative 7 times the x is a negative 7x. If I multiply negative 7 times a negative 2, I get a positive 14. So I now have y minus 6 is equal to negative 7x plus 14. Now what I want is the slope-intercept form. So what I'm going to do next is go ahead and move that 6 to the side by adding 6. So I now have y is equal to negative 7x. If I add 14 plus the 6, 14 plus 6 gives me a 20. So I now have my equation in the slope-intercept form, which is y equals negative 7x plus 20. So this is how we find the slope-intercept form if we're given 2 points, 2 ordered pairs. Now keep in mind I still have to convert this y equals negative 7x plus 20 into our standard form. So that's what I'll do next. So let's go ahead and take that equation and convert it into our standard form. And standard form is ax plus by equals c. So I've got my equation, y equals negative 7x plus 20. First thing I'm going to do is take that negative 7x and move it to the left. And in order to move it to the left, I'm going to add it. So this now is going to become a positive 7x. Still got my y. And it equals to a 20. Now notice the equation has no fractions in it. The value of a, or the number in front of the x, is a positive number. So everything is good here. I am done. I now have my standard form of the equation that contains those 2 points, 2, 6, and 4, negative 8. Now remember, in my example, I used that ordered pair 2, 6. Had I used the ordered pair 4, negative 8, I still would have ended up with these same two equations. So this is why I say it doesn't matter which ordered pair you use. Both result in the same two equations. Okay, next example we have. This time we're working with the 2 points 1, negative 3 and negative 2, negative 1. As I mentioned, we're going to start by finding the slope using this little formula here, y2 minus y1 divided by x2 minus x1. This is how we find our rate of change, or our rise over the run. So here we go. y2, that's our negative 1. We're going to subtract the first y value, which in our case is a negative 3. And then we'll do the same thing with the x's. We take the second x, which is a negative 2, and we'll subtract the first x, which is a 1. So let's go ahead and subtract here. Negative 1 minus a negative 3 would be a positive 2. A negative 2 minus 1, negative 2 minus 1 is a negative 3. Now in this case, this fraction can't be reduced, so I'm just going to leave it as negative 2/3. So the slope we're going to be working with here is negative 2/3. Now that we have our slope of negative 2/3, we can now move on to the next step, which is using the point slope form. That's that y minus y1 equals m times x minus x1. Now the reason we're using this is because we have a slope, and we're also going to use one of these points. Now remember, the choice is yours. You can use the point 1, negative 3, or you can use the point negative 2, negative 1. In my case, I'm going to go ahead and use that first order pair. So what I'm going to do is I'm going to replace this y1 with the y value, which in our case is a negative 3. Remember, m stands for slope. I just found that. That's a negative 2/3. And the x1, remember we're using that first ordered pair, and the x value in that first ordered pair is a 1. So here's what it looks like with all the values plugged in. Now to make this look a little nicer to work with, these two negatives is now going to make this a positive 3. Now what I'm going to do is use some distributive property. Negative 2/3 times x is a negative 2/3 x. Negative 2/3 times a negative 1 would make this a positive 2/3. Now I'm almost there. I've almost got y by itself. The last thing I'm going to have to do here is we're going to need to subtract 3. So we're going to do 2/3 minus the 3. Now I'm going to go ahead and write this in the form of a fraction. So if I subtract 3 from that 2/3, 2/3 minus 3 is going to give me a negative 7/3. So I now have my equation in slope-intercept form. Y equals negative 2/3 x minus 7/3. Okay, the last thing I'm going to do is take that equation y equals negative 2/3 x minus 7/3 and convert it into our standard form. That's that ax plus by equals c. So here we go. And there's the equation. We're going to start off by moving the x to the left of the equation, which means that's going to become a positive 2/3 x plus y equals negative 7/3. Alright, so as you can see, I do have a small problem with this equation. I have not only one fraction, but two fractions, and I need to get rid of those two fractions. So here's what I'm going to do. I'm going to take this whole equation, and I'm going to multiply it by a 3. And the reason I'm multiplying by 3 is because when I multiply by 3, it's going to take care of both of those fractions. So as you can see, what's going to happen when I multiply 3 times a 2/3? 3 times 2/3 is going to give me a 2x. 3 times my y is going to give me a 3y. And if I multiply 3 times a negative 7/3, 3 times negative 7/3 is going to give me a negative 7. So notice by multiplying by that 3, I've taken care of both of the fractions. Therefore, I now have my standard form. So this is our standard form given those 2 points, 1, -3, and -2, -1.